Hello everyone and welcome to my channel that is Learning Under 10 by Dhruv. Today I will be taking certain geometry problems which was shared by one of my students. So let's start discussing that particular problem. The first problem says there are two squares with length A and B where A is greater than B are placed together such that the right side of a square with side A touches the left side of the square with side B and their bases are in collinear. So we are talking about two squares where A is greater than B and the left side of a square B is touches the right side of square and their base are in collinear. A line is drawn from the bottom left corner of square A to the top right corner of square B. This has been done. What is the area below the line in the square of side A? Now I need to find this particular area. Now there might be problem, might be possibility someone says that give me this point and I would be able to find the area under this particular line. Why? Because I can easily see a right angle triangle. If I know that particular point with the help of coordinate geometry, I would be able to solve this particular question. But suppose if I give this coordinate as, let's say, m, I give this coordinate as n, o, p, q. Now, can I say these two lines are parallel? This is 90 degree, so I can say these two lines are parallel. And whenever two lines are parallel, you always have to consider that there is a concept of similarity which is going to apply there. So from there, I can say that is triangle MNQ is similar to triangle MOP. Can I say this thing? With this thing, I can say that MN upon MO is equal to MQ upon MP is equal to NQ upon OP. I can say this thing. Now I know that the side of this particular, triangle will be A, this is B, and this is B. So I know MN. MN will be A upon MO, which is A plus B. MQ, I don't know, I don't care. MP, again, I don't know, I don't care. NQ, I don't know. And OP will be B. Now, we also know that, you know, if I take a square of this thing, A upon A plus B whole square, this ratio will be the area of MNQ upon area of MOP. The best part is I know the area of MOP. If I apply the concept of right angle triangle, I know the area would be half into base into height. So I can say A square upon A plus B whole square is equal to area of MNQ upon half into A plus B into B. From here, A plus B will cut. I need to find this thing. So the area comes out to be half multiplied by A square B upon A plus B. So that will be the answer for this particular question. I hope this is clear to everyone. Now there's another good question that we got. The alternate vertices of a regular octagon are joined to form a quadrilateral. Find the ratio of the area of a quadrilateral formed to that of a octagon. Now, understand this thing as well. Whenever we have a figure like hexagon, whenever a figure like octagon or decagon, we are talking about even sides. And here also the question is saying that we are joining alternate vertices. So there is a certain sense of symmetry that we're going to apply. I'm not sure whether we can apply symmetry or not. And it is not always true that you have to apply symmetry. But in 90% of cases, you have to apply symmetry in such cases. Now let's try to see how we're going to solve it. First of all, let's try to draw a octagon. Is this the octagon? 1, 2, 3, 4. 1, 2, 3, 4. Yes, it's octagon. The question says joining alternate sides of a figure. We have joined this thing and we have joined this thing. We need to find out the ratio of this particular area to the total area. Now, if I need to find out what is the regular angle of a octagon, can I find that thing? It's a regular octagon. So I can simply divide 360 by 8. This comes out to be 8 4s are 32, 45 degree. This is external angle. Internal angle will come out to be 135 degree. So that means each angle will be 135 degree. If it is 135 degree, that means, and this area, when we talk about triangle, 180 degree, and both sides are same. So I can say this will be 22.5 degree. This will be 22.5 degree. Similarly, with the help of symmetry, I can, this is also 22.5. This is also 22.5. Considering this is complete 135, this angle becomes 90 degree. Again, 90 degree, 90 degree, 90 degree. That means we are talking either of a square or a rectangle. But now if you see, there's a symmetry. All sides are equal. That means I'm talking about a square. Bingo. My work is done. Now let's try to see how to solve this thing. Let's try to join the sides of a octagon. Opposite sides of octagon. Yeah. Okay. As I've joined the regular sides of octagon, can I say all these lines which I have drawn are equal? If I say this side is A, this side is also A, you know, they're dividing the square in equal side. And the area of a quadrilateral because of this thing will be 2 acre whole square, which comes out to be 4a square. That's the area of a square. Yeah. So I know the area of a quadrilateral. Now the question comes how to find out the area of a octagon. Yeah. Okay. Let's try to see that thing. As we know, you know, the complete, this is what a complete diagonal, you know. And if my side of a square is 2a, the diagonal will be 2a root 2. Can I say this will be this will be the half of the diagonal, and the half of diagonal will be a root 2. This is a root 2, and this will be 2a. Can I say? Can I also say we are getting a kite here? We are getting a kite here. We're getting a kite here, and we are also getting kite here. Well, we have 4 kites. Area of one kite is equal to half into d1 into d2. Here, 1d1 is the side of a square, which becomes half into 2a, and other d1 will be the half diagonal of a square, which is a root 2. So and there are 4 kites, so I have to multiply it by 4 as well. The area comes out to be 4a square root 2. This will be the area of octagon. Now I'll find out the ratio of area of a quadrilateral to that of an octagon. So that means 4a square divided by 4a square root 2. But and I'll get the answer as 1 by. I hope this question is very clear. So we have solved it with the help of symmetry. Another question, another good question, I would say, um, where a trapezium is given to me, where individual sides of a trapezium is also given to me, that is ABX. where AB is parallel to FE and FE is parallel to DC. I have to find out the value of X where it is given that area of ABEF is equal to area of ECDF. Now, again, I'm finding the parallel lines. So, what I'll do, I'll try to extend it like this, and I'll keep this value as Y. As I said, parallel line, I don't have to prove that whether these triangles are similar or not. I can easily prove them. So, can I say triangle YAB is similar to triangle YFE? I can prove that thing. Like, yeah, definitely I can say this thing. Through this way, we can say AB upon EF is similar, and this will be like its square should be equal to area of triangle YAB upon area of triangle YFE. Can I say this thing? Yes. And if I need to find out the area of AFBE only, right, what I can do? I can simply do 1 minus AB by EF whole square, which give me area of WYFE upon minus area of triangle YAB upon area of triangle YFE. Can I say this thing? And what will going to happen from this way? I would be able to get the area of AFBE only. So this is nothing but area of ABEF upon area of triangle YFE. Now, another thing what I'll do, I'll try to see, you know, similarly triangle YFE will be similar to triangle YDC. And similarly, I can say, uh, if I apply to this concept, 1 minus FE square, FE divided by CD square, I can say this thing is equal to area of FECD upon area of YCD. I can say this thing. Now, the only problem that will lie for me is I don't have YFE and YCD concept here. So let's try to do one thing. Instead of taking it from, YAB by YFE, let's try to take it YAB upon YCD. If I take that thing, I'll get similar concept AB by CD whole square. I take 1 minus should be equal to area of ABCD upon area of YCD. I hope this is clear to everyone. Yeah. Now, if I divide these two equations, what I'll get? CD square, we know CD square is x square. Now. So we can say x square minus b square upon x square is equal to FECD upon YCD. This is first equation. Second equation, I get x square minus a square upon x square is equal to area of ABCD upon area of YCD. If I divide these two equations, I get x square minus b square upon x square minus a square is equal to area of ECDF in this definition upon area of ABCD. Now it is also given to me that the area of ABEF is equal to area of FECD. So ABCD is what a combination of both things. So can I say the ratio of these two things will be 1 by 2? If I say this thing, if I try to solve this thing, so I'll get from here, I'll get twice of x square minus twice of b square is equal to x square minus a square. I try to solve it. X square becomes 2b square minus a square, and x becomes under root of 2b square minus a square. I hope this question is also clear to everyone. All the three questions, barring second, are belong to similarity, and similarity is one of the very important concept of geometry. Generally, it has been seen that 3 to 4 questions which we have seen of geometry in the paper, one question is definitely there from the similarity concept. So this is very, very important. Don't leave this particular concept. This is quite simple. And if you have any further queries, do mail me at queries@truequell.in. Till that time, thank you very much.